Example 1 would get us to sketch these three equations on our CAS calculator, and then we'll do it by hand. And we're actually just going to look at, I suppose, what the f plus g graph looks like in comparison to the other two. So first step, let's just graph them into our CAS calculator. So we're going to input x squared, pressing tab to open another equation, graph x. And then lastly, we will graph x squared plus x, which is literally just our functions added together, so x squared plus x. Now, you might be able to see that we've just moved ourselves slightly over. I'll zoom in a little bit so we can see. So the black graph, which is our f plus g graph, has moved across very slightly and down. And we're going to look at some of these key points and see what it actually, or how we can create this by hand. Alright, graphing by hand, we're going to start with x squared, just plotting the key points. So 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Noting that we have that symmetry property, so we can, I suppose, just get those second points. Our linear equation, which is the equation of x, again plotting some points and drawing my line in. Now the next part of this, which is the green equation, so f plus g, I'm literally going to take my points and add them together, and I add my y values. So for instance, this point here, which on both red and green graphs is 0, 0 plus 0 is 0, so one of my points is going to actually be on the origin right here. If I go 1 plus 1, that makes me at 2, so I'll have a second point up here. This point is at 2 and at 4, so I should have a point that's at 6. If I go over here and do the same sort of thing, -1 and 1 is actually 0, so I'm in here. Then I could do -2 and 4, which is going to give me a point at 2, and etc. from there. Now, what I'm essentially doing is graphing a quadratic, but I'm moving it across a little bit. So my turning point is down here. My turning point is where the size of my red graph gets larger than the blue graph. So it's when the distance between the x-axis and the red graph and the blue axis and the x-axis and the blue graph is equal to each other. We're also going to look at this using a table of values. So in our calculator, we can actually create a lists and spreadsheets page. So menu, add a lists and spreadsheets page. And we're not actually dealing with a spreadsheet. We want to deal with a table. So if you go menu, and you can change that into a table. Now, using the little arrow in the top corner, I'm going to insert F1, F2, and F3. F1 is what I've input just before, so that is my x squared function. Then I can input F2, which is my x function, and x3, which is the two added together. These are my coordinate points. So you can see the coordinate points for each of my, I suppose, integer values for all of my equations. And that's what I'm going to input into this table here now. So for all of them, they all exist at 0, 0, and then stuff changes. Now, we're looking for the pattern that exists between these. And what you'll notice as you go through and do this is if you take the first value, 1, 4, 9, or 16, and add the second value, 1, 2, 3, and 4, you end up with the third value. And this makes sense. It's the addition of ordinates. The addition of the y values is to give the new equation or the new function. So 4 plus 2 is 6, 9 and 3 is 12, and 16 and 4 is 20. Our function x squared plus x is given by these points. This will work exactly the same way for a subtraction. So if I had x squared minus x, it would be 0 minus 0, 1 minus 1, 4 minus 2, etc., etc.